Okay, now we have a whole bunch on one page because they're so easy to do. We can blast through them without spending a whole lot of time worrying about it. Okay, we are squaring this, so that means that you take the first term, 2a, and you square it. 2a times 2a, 4a squared. And then you take the two terms and you multiply them together and double it. So 2a times b is 2ab. If we double that, we get 4ab, and it's positive. And then for the last term, we take what's at the end, in this case it's b, and we square it. B times b, b squared. Yep, that's the answer. Okay, let's do it for 41. We're squaring a binomial, so we square the first term, 8r times 8r, 64r squared. And then we multiply the two terms together and double it for the middle term. So 8r times negative 5s. Well, 8 times negative 5 is negative 40, and then the variable is rs, r times s. So negative 40 rs, when doubled, negative 80 rs. And then the last term squared, negative 5s times negative 5s, positive 25s squared. That's the answer to that. Oops. Moving on. We say we're squaring this binomial, so we square the term in the front. G times g, g squared. We multiply them together and double it for the middle term. So g times negative 7h is negative 7gh. Doubling it is negative 14gh. And then we square the last term for the final term. So negative 7h times negative 7h, positive 49h squared. That's the answer. This is why these are those special cases, because they all follow the same rules and we can do them quickly. Okay, one more of the squaring the binomial. Okay, p to the fourth times p to the fourth, p to the eighth. Okay, now we multiply them together and double it for the middle term. So p to the fourth times negative 9 q squared, you get negative 9 p to the fourth q to the second. Doubling that is negative 18 twice negative 9. P to the fourth q to the second. That's its own term. And then for the last term, we do the final term in this, negative 9q squared, and we square that. So negative 9 times negative 9, positive 81, and q squared times q squared, q to the fourth. That's the answer. They go fast, right? And then recall now this second bit down here. Okay, we've got, get some new fresh colors in here. We've got a minus 6b times a plus 6b. And what do we do with those? Well, in this particular case, we have to just square the front term, square the back term, and that's all we have to do. We subtract in between them. A is the first term on both of them, a and a, so we square that to get a squared. Okay. The last term here is 6b, so we square that to 36b squared. And it's always subtraction in between them, so we got a squared minus 36b squared. Okay, and that's the answer, so I'm going to box it. Now, we're doing the same thing. We're multiplying r squared plus 3s times r squared minus 3s. And since they're basically the same but with opposite signs in between, we square the front term, r squared times r squared, r to the fourth. Square the back term, 3s times 3s, 9s squared. And with subtraction in between them, we subtract. Yep, and there's just one more to go. And you see we're doing 3w cubed minus z squared times 3w cubed plus z squared. Exactly the same, but with different signs in between. So we square the front thing, the front term, 3w cubed times 3w cubed becomes 9w to the sixth. And then the last term squared, z squared, or z squared times z squared is z to the fourth. And it's always subtraction in between them. That's what you get. Not bad. We did a whole bunch of problems really fast because they're pretty straightforward. They all follow the same set of rules.